The binomial theorem is what we, in fact, don't have too much time for, but I wish we did because it has so many applications, one of which is when you are in statistics looking at probability. There's something called binomial probability that is very useful when you have a choice of one thing happening or not happening. But what we're going to do is use this to expand a polynomial. And this notation, you understand most of it. We never talked about this notation, and this is called, this is a combination. In fact, it's called n choose k, and I'm not really going to go into what that means because we don't have time, but I'm just going to give some examples. So here's example number one. Suppose you had something like this, a plus b, and you needed to raise it, I don't know, maybe to the 7th. What I told you to do earlier in the year is to use Pascal's triangle. So I'm going to scribble that. In fact, let's make this a little bit better. Let's make this to the 4th. So I'm going to scribble out Pascal's triangle. And what I know is that this row is going to give me really the expansion for the coefficients. So I can write this. I know my first term is going to be a to the 4th plus my next coefficient is going to be 4. But then I'm going to have a little pattern with the exponents. The exponent on a is always going to go down by 1. B is going to go up by 1. My next coefficient is going to be 6. I'll have a squared, b squared. My next coefficient is going to be 4. I'll have a to the 1st, b to the 3rd, and then my last coefficient is going to be 1, and I'll really have a to the 0 and b to the, 4th. Okay, and that's one way of doing it. But there's another way of figuring out what these coefficients are, and I'll show you what it is, and that's what this binomial theorem is really saying. So the other way to do it is this. A plus b to the 4th. So I know I'm going to have this pattern of exponents, but as far as the coefficients is concerned, well, it's always a matter of looking at your previous term. So I know I'm going to start with a to the 4th. Okay, for my next coefficient, so for my second term, I'm going to look back at the first term. And what I'm going to do is I'm going to multiply the exponent times the coefficient. So that's going to give me a 4. And then I'm going to divide it by the term number. So that's the first term, so I would divide this by 1. I'm going to leave it. And then I know I'm going to have a to the 3rd and b to the 1st. Now, I'm going to, in fact, I'm always just focusing on the exponents of the first term. So for my next term, so in fact my third term, I'm going to look back at my second. And what I'm going to do is multiply 4 times 3, which is 12. But since this is the second term, I'm going to divide that by 2. And then I'm going to have a to the 2nd, b to the 2nd. Okay, so let's just realize that's really a 6. For my next term, for my coefficient, I'm going to multiply 6 times 2, but then I'm going to divide that by 3, since that had been my third term. And then I'll have a to the 1st, b to the 3rd. Okay, we all recognize that's really a 4. And for my next term, I'm going to multiply 1 times 4, which is 4, but then I'm going to divide by, let's see, that's the 1, 2, 3, 4th term. And then I'm going to have a to the 0, b to the 4th, so we end up getting exactly what we would have predicted. 4, a to the 3rd, b to the 1st, 6, a squared, b squared, 4a, b to the 3rd, plus 1, a to the 0 is 1, b to the 4th. So I'm going to shut this off, and then I'm going to do another example on the next video.